Hey everybody, I'm Silas, and welcome to Psilocybology. Let's expand our mind. This is a series where we talk about the research on psilocybin, the psychedelic prodrug found in magic mushrooms. We'll be breaking down and discussing the scientific literature, one study at a time, from past to present. If you'd like to support the show, please consider becoming a patron through Patreon, where you can opt to give either $1, $2, or $5 per episode in return for some cool perks to show my appreciation for your help in sustaining the podcast. With that, let's get started. Today's episode is on two articles that were published by the same research lab at Ohio State University, both of which examined how psilocybin induces the experience of time contraction, meaning a slowed perception of time, for example, that minutes appear to be hours. The primary article we'll be discussing is titled Psilocybin Reactivity and Time Contraction as Measured by Psychomotor Performance, published in 1966. The secondary article we'll be discussing is titled Quantitative Measurement of Time Contraction Induced by Psilocybin, published 2 years later in 1968. Starting with the first paper, the authors note that interest in this field comes out of prior reports that people experience time contraction in response to smoking cannabis or taking mescaline. What was particularly interesting to me was that the authors actually made a connection between the perception of time and the perception of space. They noted that in response to certain drugs, as time appears to contract, space begins to extend. The authors made the point that some drugs create the sensation that distances were longer than they were under normal conditions, or that people's legs or arms felt longer than they were normally. Given these simultaneous experiences, the authors hypothesized that psychedelics, and in this case, psilocybin in particular, alter our perception of space-time by producing an overestimation of clock time, i.e. time contraction, and a concomitant expansion of space. In order to test this hypothesis, the researchers decided to administer two tests, one that measured changes in handwriting, and another that measured changes in tapping speed, after being given psilocybin. Before getting further into this study, I want to say that although this topic is very interesting, this is by far one of the least rigorous studies we've come across and is not a very well put together manuscript, because it leaves out a ton of key information about the study, while also including a lot of unsubstantiated claims that are never cited by the authors. So far, this is a common theme that appears to be prevalent in a lot of the work by this research group, unfortunately. The second paper that we'll be discussing today seems better written, but it actually has some of its own flaws that are more nuanced but much more serious. Anyway, one of the problems with the first paper is that for the writing task, data are only reported for 4 participants, and in the tapping task, data are only reported from 2 participants. I assume all the participants were male because they note that the 2 in the tapping task were, but they don't specify what the other 2 were in the writing task. Not only is this a problem due to the small, homogeneous sample, it also bothers me that it looks almost like they cherry-picked data to include in the paper, because the data from the 2 additional participants who completed the writing task were used to support the author's claims, which we'll bring up in a bit. It makes me wonder why were data on 4 participants included from one task, but only 2 in the other. It makes me think some of the data from the tapping task may just have went against their hypothesis, so they didn't include it. Which is maybe me just being cynical, but the burden of proof is always on the researcher. Another problem is that although they somewhat describe the tapping speed task, they don't really describe the writing task at all. Specifically, they don't mention what instructions participants were given, how much time they had to write, and most importantly, whether participants were given a prompt or if they were just told to write whatever, or if they were copying a specific passage that was pre-written. These factors all obviously could have an influence over how to interpret the results. So without this detail, we can't evaluate any claims using the data. Another thing that really bothered me about this paper is that based on the participants' data, they labeled them as either non-reactors, mild reactors, reactors, and strong reactors. The issue I have isn't with categorizing participants based on their responses. In fact, I very much think rigorously applied descriptive statistics are really valuable. My issue is that they made these categories based on 4 participants, and they didn't appear to use any other measures to provide some convergent validity. What I mean is they never appeared to confirm a non-reactor was in fact someone who didn't respond to psilocybin, by either asking them via self-report whether they subjectively felt any effects, or by taking other measurements that we know are associated with psilocybin, such as assessing changes in pupil diameter. It's possible the handwriting of the one non-reactor didn't change, but they still felt the effects of the drug. Saying someone is a non-reactor to psilocybin based on one outcome assessed at only one point in time is like saying someone is insensitive to the effects of caffeine because this one time they drank it, it didn't make them have to poop. With these issues in mind, let's talk about what it is the researchers report to have found. Starting with the handwriting task. As I mentioned, I have no idea what the procedure was. However, the main outcome was specifically the size of the participant's handwriting prior to and 90 minutes after taking 0.115 milligrams of psilocybin per kilogram of body weight, so about 8 milligrams for someone weighing about 154 pounds. The measure of handwriting size was believed by the researchers to indicate a perceived expansion of space. This was reportedly based on prior studies that found the administration of tranquilizers caused patients to have smaller handwriting, and they believed tranquilizers also caused patients to perceive space as smaller. Therefore, if psychedelics did the opposite and caused space to expand, then the researchers thought it would also cause handwriting size to increase as well. I'll post the images of the handwriting on the podcast Instagram, just so you guys can see it. But essentially, the researchers reported in the paper that for participants who reacted to psilocybin, psilocybin increased the size of their handwriting. They included writing samples for the so-called non-reactor, whose handwriting didn't change, and then labeled the other 3 participants as a mild reactor, reactor, and a strong reactor based on how much larger their handwriting was after taking psilocybin. This to me is really unconvincing on its own. I definitely don't believe, based on the data presented, either that handwriting size is a good measure of one's perception of space, or that the absence of a change in handwriting size indicates a lack of response to psilocybin. Anecdotally, after reading this study, I went back and looked at some of my own handwriting, from journal entries I've written either under normal conditions or after taking psilocybin, and I don't see much difference, particularly not with respect to the size of my handwriting. What also seemed like a missed opportunity to me was not measuring how fast participants wrote. Although they used this measure to assess perception of space rather than time, it feels like it could have easily been used to assess both simultaneously. Let's move on to the tapping task. For this test, 2 participants were given a telegraph key, which is used for Morse code, to use for tapping. During one of the 8-minute sessions, the 2 participants were supposedly told to tap at a freely chosen tapping speed. In the second 8-minute session, they were told to try and tap at a consistent speed of 1 tap per second. The sessions were done once before and once 90 minutes after, being given the same dose of psilocybin used in the handwriting experiment. First off, they found that the tapping speed of the 2 participants, when told to try and keep a steady rate of 1 per second, didn't change after they were given psilocybin. When they were allowed to freely choose their tapping speed, however, the tapping speed of both participants increased 90 minutes after being given psilocybin. According to the researchers, this proves that psilocybin produces time contraction. Now, from a plethora of reports by people who have taken psilocybin, from plenty of better quality data that we'll come across later in the podcast, and from my own experience, I have no question that psilocybin does in fact slow down our perception of time. However, I'm not convinced that tapping speed is a good measure of this time contraction, at least not based on this 1 2-person sample experiment that wasn't well described. Overall, I thought the concept behind this study, particularly that psilocybin caused a simultaneous expansion of space along with a contraction of time, was interesting. I also think that I came away with some cool ideas for future studies that could better assess this phenomenon. That said, there's no data from this study I would use to make any claims about the effects of psilocybin. So as I mentioned earlier, the second paper for today was a bit better written, but includes its own problems. Whereas the paper we just discussed used handwriting size and tapping speed as measures of space expansion and time contraction, respectively, this second paper focused just on time contraction and assessed the duration of pauses taken when participants were reading a pre-written message. Importantly, the authors hypothesized that they expected psilocybin to produce changes to the duration of pauses, but did not specify in what direction, i.e. whether pause duration would increase or decrease. For this study, they used 7 males and 5 females. 3 of the participants notably did the experiment twice, so in their analysis, their sample size was 15 trials. For each trial, participants read a 228-word passage once before and once 90 minutes after, being given between 0.125 and 0.174 milligrams of psilocybin per kilogram of body weight, so roughly between 9 to 12 milligrams for someone who weighed about 154 pounds. Their readings were recorded so that the pause durations could be measured. Now, they don't say whether it was the same passage before or after, which is the first glaring problem I came across. As you read the same passage multiple times, it becomes more familiar, and my own hypothesis would be that as you get more familiar with a passage, the duration of pauses would on average decrease. What bothered me even more about this study, however, was how the data were presented. The researchers reported that for 10 out of the 15 trials, the median pause duration decreased after participants were given psilocybin. And for 5 out of the 15 trials, the median pause duration increased after participants were given psilocybin. What the authors do is break the data into 2 subgroups, depending on whether pause duration decreased or increased. They then tested these subgroups to see if the results were statistically significant. And they found that for each subgroup individually, the changes did appear to be statistically significant. In the group where pause duration decreased, it decreased by an average of 5 milliseconds, and in the subgroup where it increased by an average of 5.12 milliseconds. They then stated, quote, "All 15 subjects as a group show a significant shortening of the median pause duration at the same level of significance as when the 2 subgroups are considered separately." That statement, however, is false. Fortunately, because they provided all of the numbers in a table, I was able to rerun their 3 analyses examining the 2 subgroups as well as the overall group. The 2 subgroups did see statistically significant changes to pause duration, but when you looked at the overall sample, combining the 15 trials, there were no statistically significant changes to pause duration produced by psilocybin. To be clear, I'm saying that this paper is making a fraudulent claim and should not have been accepted for publication. Unfortunately, this is an example of what happens surprisingly often in research and academia. Claims are falsified. This is also a great example of how the term peer review is absolutely meaningless. I've been a reviewer for some publications, and let me tell you what it often involves in broad strokes. A researcher submits a paper for publication to a journal, and the journal then sends the paper to reviewers who are asked to read it and provide feedback as to whether it should be accepted or rejected. These reviewers do not have to be trained in reviewing manuscripts. During the review process, often all you have to look at is the submitted paper, never the actual data or the statistical analysis plan or some of the original documents that were used in actually conducting the experiment. Peer reviewers are not like auditors who come in and make sure everything they did is well documented and nothing is falsified. Peer reviewers are much more like copy editors who give feedback on how the paper is written rather than on how the experiment was actually conducted. Peer review, as it currently is set up, should not be a gold standard because it is a horribly low bar. But anyway, getting back to the paper. What this tells me is that the authors manipulated the data because they didn't want to publish a paper without any positive findings. Again, like the last paper, the idea that psilocybin causes time contraction really isn't what's being questioned here, but rather it's the claim that pause duration is an accurate measure of time contraction, which clearly does not seem to be the case from these data. I think it's much more likely that any decrease in pause duration was simply a result of familiarity with the passage. Also of note is that for 2 of the 3 participants who repeated the experiment, the first time they did it, they were in the subgroup where the pause duration increased, but the second time they did the trial, they were in the subgroup where pause duration decreased. So although both studies were sort of trash, I did actually want to revisit something the authors mentioned in their introduction and discussion that I do think has some value. In these papers, the authors note that they believe the mechanism underlying psilocybin's effect on our perception of time comes down to its effect on our metabolic rate. The authors make reference to the idea that higher metabolic rates produce a slowed perception of time, whereas lower metabolic rates produce a faster perception of time. This is why, according to the authors, time passes more slowly when we're young and speeds up as we grow older and our metabolism slows down. I did some background reading and came across a cool study titled Metabolic Rate and Body Size Are Linked with Perception of Temporal Information, published in 2013. The paper used critical flicker fusion frequency, or CFF, as their measure of temporal information, which, if you remember back to episode 17, is the lowest frequency of flashing, at which a flickering light source is perceived as constant. This is related to frame rate. If the frame rate is below the given CFF, flicker will be apparent and the movements of objects will appear jerky. What's important is that the higher the CFF, the greater ability to perceive moving visual information. In the paper, they compiled data from 34 different species, including humans, and analyzed the relation between metabolic rate and CFF. What they found was that as the metabolic rate of organisms increased after correcting for their body mass, so did the CFF. They noted that according to their model, small animals with high mass-specific metabolic rates had the highest maximum CFF, and conversely, large animals with low mass-specific metabolic rates had the lowest CFF. Now, recalling again back to episode 17, although it was a small study and would need to be replicated, the authors did find that CFF increased in humans after being given psilocybin. What's so cool about these 2 pieces of data are that it does seem to support this link between psilocybin, metabolism, and time contraction. Although we weren't able to take away a lot from the 2 main studies we discussed today, I do think we can come away with at least an initial look into what biological mechanisms may be influencing the perceived time contraction that is produced by psilocybin. That's it for today's episode. As always, I really hope you enjoyed the show. If you have any questions, feedback, or ideas for the podcast, please let me know. You can find out all the ways to reach me on the website, psilocybology.org, where you can also find the full transcript for each episode if interested. Thank you all for listening, and I'll talk to you next time.